All right, so today we're going to look at how we can graph quadratics in vertex form. So we're going to learn what the vertex form of a quadratic is, and we're going to learn how to graph a quadratic. So just like when we did linear equations, we had point-slope form, we had standard form, and we had slope-intercept form. Well, with quadratics, we're going to look at vertex form and standard form, and we're going to start with vertex form. So vertex form is this form right here, f of x, or remember that's the same as y, equals a times x minus h squared plus k. Okay. And this is important, and we call it vertex form because we can see the vertex. So remember from our lesson on the different quadratics that when we look at the vertex, okay, this is your vertex. Or if it opens down, this is your vertex. Okay, this is a minimum, and this is a maximum. So our vertex is h and k. So I can look at this graph and I can see that h and k are my vertex. A is kind of like our slope, okay? If a is positive, it's going to open up. So it's going to open up like this. If a is negative, it's going to open down like a frown. It's going to open like this. Okay, a will also tell us how wide it is. And we're going to use a to graph other points. So we're going to find the vertex of our equation when we're going to graph, and then we're going to use other points by going from the vertex. And remember, we have an axis of symmetry. So from our vertex, because this is squared, I'm going to go over 1 and up 1. Okay. Then from that vertex, I'm going to go over 2, and then I'm going to go up 2 squared, or 4. And then I'm going to go over 3, is the purple, and up 3 squared, or 9. And then I'm going to do it on both sides, right? Because of that axis of symmetry. And that's what gives us that curved shape. Just kind of goes right here with our curved shape. All right, so when we go to graph and vertex form, remember that when we had point slope form, which was this y2 minus y1 equals m times x2 minus x1, your point that you started with was that x1, y1, and they were opposite. It's going to be the same here because of this negative. It's going to be the opposite in here, but this is a positive, so that will be the same. So my vertex for this is going to be the opposite of that, so 3, negative 4. So I'm going to go over to 3 and down to negative 4. Okay. Now I said in the last slide that I'm going to go over 1, and in this case, because there's nothing in front of here, or it's a is equal to 1, I'm going to go over 1 and up 1 squared times my a, which was 1, or 1. So from that vertex, I go over 2 and up 1. Now remember, we have an axis of symmetry through here, which is that line x equals 3. So I'm also going to have a point, 1 point over, because I've got a mirror image. Going to go over 2. And now I said I'm going to go up 2 squared times 1, which would be 4 times 1, or 4. So I'm going to go over 2. I'm going to go over 2 and up 4. Okay. And then, if I go over 3, I'm going to go up 3 squared times 1, or 9. So we're getting this squared. So why we're going up by squareds is because this is a quadratic and it's squared. So I'm going to go over 3 and up 9. So right here, 3 over to the axis of symmetry, and 3 over this way. And now I've got my quadratic. So if I'm going to graph this equation, I'm going to leave the vertex form up here to remind you of what it is. Okay, this is my h and this is my k. And just like in point slope form, we're going to go the opposite. So my vertex is going to be 3 and 4. So I'm going to go over to -3 and up to +4. And because this is negative, it's going to open down. So I'm going to go over 1 and down 1 on each side. Okay, so I went over 1 and down 1 squared. I'm going to go over 2, and then I'm going to go down 2 squared. So from my vertex, I go over 2 and down 4. So right here. And on both sides, because I've got that axis of symmetry that goes right through here. Remember, that's not really a part of the graph. It's just that axis that we can look at things. Then I'm going to go over 3 and down 3 squared, which is 9. So for my vertex, I go over 3 and down 9. Right there. Here's my axis of symmetry. So 1, 2, 3, 1, 2, 3. And there is my quadratic. Okay, in this case, my vertex again is -2 and 7. So I'm going to go to -2 and up to 7, which is here. And notice that this is -1/2. So I'm normally going to go over 1 and down because it's -1, but what I'm squared. But what I'm going to do is I'm going to multiply that by my a of 1/2. So that gives me 1/2. So I'm going to go over 1 and down 1/2 on each side of that axis of symmetry. So there's my axis of symmetry, right? Normally I go over 2 and down 2 squared, but I'm going to multiply that because of that half. A is 1/2 by 1/2. So that's 4 times 1/2, or 2. So I'm going to go over 2 from the vertex and down 2. Okay. I go over 3. I normally go down 3 squared times 1/2. So 9 times 1/2, or 9/2, which is 4.5. So over 3 and down 4.5, halfway between. And I can even take it further out because we got room on this graph. If I go over 16, or I'm sorry, over 4, I'm going to go down 4 squared times 1/2, or 16 times 1/2, or 8. So if I go over 4, I'm going to go down from the vertex 8. So I'm going to go here and here. Now in this case, notice that it's not really written. It doesn't look like it's written the same way. But my h is in that squared, so we can think about this and rewrite this as x In order to just make it x squared, that's got to be a 0, right? Minus 5. So my vertex is 0, -5. So I'm going to go down to -5. And then because of this 3, normally I'm going to go over 1 and up 1 squared. But now I'm going to multiply by 3. So I'm going to go up 3. So over 1 and up 3 on both sides of my axis of symmetry, which in this case is x equals 0. Okay. Normally I go over 2 and I go up 2 squared, which is 4, and 4 times 3 is 12. So I don't know if I have enough room. Let's see. I go over 2 and I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What do you know? I have exactly enough room. So that 3 makes this really, really skinny. All right, so today we looked at how to graph a quadratic when it was in vertex form. Our vertex was h and k. A told us how much we're going up each time we move over one space from the vertex, or down if A is negative. So have a math-tastic day.